Okay, so let's discuss about annuities with payment in geometric progression. Earlier we discussed about payments in arithmetic progression. So they look like what? Their nth term is going to be a1 plus n minus 1 time d. Okay. So in this case, if you have geometry progression, the nth term is going to be what? A time r to the n minus 1. Okay. Um, you can, so your first term is a, second term is ar, third term is ar square, so forth. Nth term is a time r to the power n minus 1. So remember that when you have geometry progression, sum is going to be what? If you want to take the sum of this term, you take a as common factor, then you have 1 plus r plus all the way up to rn minus 1. And this you can do some tricks and then get the answer, but I'm not going to prove what's the how do I get this equation, but it's going to be 1 minus r to the n over 1 minus r. Okay. Yeah, so if you really want how to get this one, you can try assuming this is equation 1 and then try the r times Sn as the second equation, and then like you multiply equation 1 by r like the same way we did in the arithmetic progression annuity proof, and then so you get r time, when you multiply everything by r you get ar plus ar square arn. This would be equation 2. So then what you do, you need to subtract 1 minus 2. That would be 1 minus r times n. By the way, now I'm proving it. I told you I'm not going to prove it, but now I'm proving it. So anyway, it would end up with a time 1 minus r by n, and then you get this nice equation. Okay, so that's the sum of geometry progression sequence. We will need it when we are when we are when we try to find the percent value of this kind of payment sequence. Okay, so so here you will get the formula right away. Let me prove at least one, and then we use the others without proof. For the arithmetic progression one, your payments start from P. The next one is P plus Q. Okay, and the nth one is P plus n minus 1 Q. Now for the geometric one, it's a little bit different. You have at time 1, it's going to be P, and then the time 2 is going to be P time 1 plus G. Okay, so G is some kind the growth rate we are using. Okay, how it's going to be. So G is the growth rate we are using, how the payments are growing. Then by the n, it's going to be 1 plus G to the n minus 1. So if I want to get the percent value, let's try to get the percent value of this kind of series, payment series. So here payments, okay, these are payments. Payments are increased by according to the geometric progression formulas. So percent value, you take the P discount to time 0, so P time V, and this one you are discounted back to time 0, P time 1 plus G time V. So all the way up to the last one. Vn. So here you can see P and V is common factor. So if I take that, I would end up with 1 plus GV, 1 plus G to the power n minus 1, V to the n minus 1. Now this, if this is R, let me write it as R. Then I can write one more line. This would be what? PV. This is not percent value, okay? This is P time V. P is payment size, okay? This is P time V. Okay. 1 plus R plus all the way up to Rn minus 1. What is R here? R is basically 1 plus G time V. Okay. So I can get the present value. So it's going to be 1 minus R to the N over 1 minus R. When I substitute back, P time V. Okay, this is not percent value. Maybe just like just to make sure that this is not percent value. This P is payment size. 1 minus R is basically 1 plus G time V to the N. 1 minus 1 plus G time V. So 1 plus G time V, V is 1 over 1 plus I. So that gives you 1 plus G over 1 plus I. So when I substitute that in here, I would get P time V time 1 minus 1 plus G over 1 plus I to the N. In here, 1 minus 1 plus G over 1 plus I. I can simplify a little bit more. So you can see what is V? V is 1 over 1 plus I. Now let me write it that here. And I have this big formula. So, you cancel out, and you would end up with I minus G. So that's this formula. So what happens if I and G are same? In that case, you can see 1 plus G over 1 plus I, or R is going to be 1. Okay. So if P and I and G are equal, then you got your payments look like this. 0. This one is going to be P. P. This one is P time 1 plus G. And then in here, N is going to be P time 1 plus G to N minus 1. And then when we write the percent value, it's PV plus P time 1 plus G time V square, all the way P time 1 plus G time V to the N. But we know that now 1 plus G time V. Okay, so this is what is basically 1 plus G time V, no? That's going to be 1. So I can write this as P time V, 1 plus G time V. That's going to be 1. The same way P time V, then 1 plus G time V, the whole thing to the N minus 1. This is basically 1. So you end up with PV, PV, N of those. So it's going to be N time PV. Okay. Basically, N time V is 1 plus I to the N minus 1. And the P is payment size. So in here you don't see the P, the payment size. If you have payment size, then you have to include P. Okay, this is basically 1 unit. Okay. If it's 1 unit, you have this kind of, but if it's more than 1 unit, you have to multiply by that unit. When you have the du, you have this other 2 equations. So let's do one problem and see how to apply this. On June 15, 1975, Roy purchased an annuity immediate with annual payment for 25 years. Annuity immediate. Okay, so on June 15, 1975, first payment is 800. It's not arithmetic, it's increased by geometric way. Okay, so it's 800 times 1.03. Next one is 800 times 1.03 square. So this is going to be for 25 years. So this is basically 0. This one is 1, 2, 3, 25. So in the 25th one, your payment would be what? 24 now. Yeah. The purchase price is based on annual effective rate of 7%. Okay, so you have discount using 7%. the payment increased by 3%, but discounting rate is 7%. Okay, so your V is basically 1.07 to negative 1. Okay, so this is annuity median. So we use that formula. The payment size is 800. Beginning one is 800. So percent value. The price basically percent value. The price meaning what's the percent value. So I'll apply the first formula. 1 plus G over 1 plus I. To the N, it's 25 years over I minus G. P is 800. 1 minus 1 plus G. G is 3%. So let me write 1.02. I is 7%. So here I is 7%. And G is 3%. So let's see what we get. So 1.03 divided by 1.07 to the power 25, then 1 minus that, divide by 0.07 minus 0.03, which is 0.04, multiply by 800. And I get 12,284.46. Now, I didn't give you any future value formula. Always remember this nice formula. You can always apply that. That's the way to get the future value. Okay, so this one says annual annuity D pays $1 at the beginning of the first year. Each subsequent payment is 5% greater than the preceding payment. The last payment is at the beginning of the 10th year. Calculate the percent value at if I use 4% or 5%. So here is 0, that's 1, 1.05. Then the last payment at the beginning of the 10th year. So that means the 9th. Okay, so we use the formula. You want to calculate the percent value. This formula, 1 plus I time. So this is 1 unit. We don't need to multiply by some number. Okay. Previous one you had multiplied by 800. So this is 1 plus I time, 1 minus 1 plus G over 1 plus I to the power N over I minus G. So let's first understand what's I. I is the discounting rate. In this case, discounting rate, first one, we can use 4%. And G is the growth rate, which is 5%. $1.04. And N is 10. We have 10 payment. See what you get. So 1.05 divided by 1.04 to the power 10. 1 minus that. It's going to be negative. Then divide by 0.04 minus 0.05. Then multiply by 1.04. Now I get 10.44. It's good enough. Okay, so the next one is the discount rate is 5%. So I equal 5%. G equal 5%. G equal 5%. So I and G are same. Then you had to use the second formula. Percent value is going to be just N. So in this case, percent value is going to be how many? Because it's only 1 unit, so it's going to be 10. Yes, 10. So it's going to be 10 for the second one. Okay, so this one says Matthew makes a series of payment at the beginning of each year for 20 years. The first payment is 100. Each subsequent payment through the 10th years increased by 5% from the previous payment. After the 10th payment, each payment decreased by 5% from the previous payment. Calculate the present value of this payment at the time the first payment is made using annual effective rate of 7%. So you have to be careful how you are setting up this problem because it's increase and decrease both. So let's draw the timeline and see, try to understand. So here is 0 at the beginning of each year for 20 years. The first payment is 100, 5%. For the 10th year. So through the 10th year, after the 10th payment, okay, so let's see. So the 10th payment, the 11th payment, I assume that's decreased by 5%. Otherwise, this is going to be a bit 0.95. For example, 12 is going to be, this is 100 times 1.05 to the 10, but 0.95 square. So it's go all the way up to the 20. Okay. So we want to find the present value. So basically we this is beginning of each year. So wait. This should be 9. Okay, because the 10th payment for annuity and due is going to be actually at the time n, time 9. Okay, sun is 10, sun 11, sun should be 19 and then 20. At 20, let's not go. This is the beginning of 20th year. This is the beginning of 10th year. Let me, so that means basically this. Let me change this. These numbers are not correct. Okay. So at time 9, when you get the 10th payment, it's going to be actually 100 times 1.059. Then the time 10, when that's when after 10th payment, each payment decreased by 5%. So it would be 100 times 1.0529, but now 0.95. Then the 11th one is 100 times 1.0529, 0.95 square. Then the 19 one is going to be actually 100 times 0.95 to 10. Yeah, we had to be careful. You have to read the problem very carefully. Okay, so present value, now we can find the present value. You discount, this one is 100 is there, but then these values you have discount to times 0. Okay, that's the formula. So so we can treat this as two-part formula equation. So we try to find the present, we try to find the value for this part first, and then the for this part next. Okay, that's our strategy. So the first part, you can see right away it's 100 is common factor. Then I have 1 plus 1.05V, 1.05 to the 9, V9. Okay. So this one is easy. If you consider this as your R, then this is going to be geometric progression. So basically it's going to be 100 times 1 minus R to the 10 over 1 minus r, where r is 1.05 times v. By the way, what's v? V is 1.07 to the power negative 1. Okay. Because that's the rate we are using for discounting purpose. Now for the second part, I'm going to take the common factor 100 times 1.059 is common factor. And then then 0.95 also common factor. And v to the 10 also common factor. So let me take all of that. What do we left? So it's 1 here. Then the next one would be 0.95 times v. In here it's going to be 0.95 to the power 9 and v9. Also, this one I can think as r, not the same r, but let's say r star. And this one would be r star to the power 9. So this one I can write 1 minus r star to the power 10 minus 1 minus r star. Okay, so basically now it's 100 times 1.05 to the power 9, 0.95 times e to the 10 times 1 minus r star to the power 10 minus 1 minus r star to the power 1 r star. So in here your r is actually 1.05 times v. In here your r star is actually 0.95 times v. Yeah, so v is 1.07 negative 1. So you please substitute and get the answer. Okay, so I'm going to leave this one for you to try since there's no more other questions. And we meet again in non-level annuity section.